Hi everyone, in today's lesson we're going to talk about how to find area between curves. If you want at any point throughout the video, please feel free to pause it and jot down any information that I have so that you're ready to continue when I am. I just found it easier to have these graphs here rather than me draw them. So here we go. Review number 1 is find the area bounded by x squared plus 3, which is this curve, and the x-axis over the interval from -1 to 2. So what I'm asking you to do is to find the area under the curve from -1 to about +2. So it's all of this area here. All right. And from the previous lessons, you should be able to tell me that we have to use integration to do this. So we're going to integrate from -1 to 2 of x squared plus 3 dx. So take a minute, pause the video, and type that in and get an answer. Hit resume when you're ready for it. All right, so I got 12. So the area under the curve is approximately 12. All right, keep that in the back of your heads for now. And let's look at example number 2. Find the area bounded by x plus 1, this line, and the x-axis over the same interval, -1 to 2. So I'm going to highlight this now here, but in a different color. So I'm going to say here from about -1 to 2. So all of this, the area under this curve. And we can use integration. So from -1 to 2 of x plus 1 dx. So again, take a minute, type that in, and hit resume when you're ready. Okay, so I got 4.5. So that's the area under that. Now, this was kind of like a review because I need it for the second part. So what if I put these two graphs together on the same set of axes? So you see how now I've put them together. And I want to find the area between the x squared plus 3, this parabola, and the x plus 1, this line, over the interval from -1 to 2. So what I'm asking you to do is kind of combine the two things together. So I'm going to show you what I have here. So we have from -1, I'll use the highlighter, sorry. So from -1 to 2 is this yellow piece, right? That's what we did from the first one. And then the second one we did was from -1 to 2, which was this piece from here down. So if I want to find the area between the two curves, what would I have to do? Well, if you can kind of visualize it, I have all of this yellow, which even went down here. So if I took the yellow, all of this, minus the red, wouldn't I be left with just this yellow piece, which is the area between the two curves? So I'll say that again. All of this area went all the way down here. So I took all of this area and I subtract off this piece and I'm left with this, all of the area in between. So there's kind of a formula. You know, we would do from interval from A to B, but we have to subtract the top equation from the bottom equation, dx. And that would be our integration. So my top equation is my x squared, or my parabola. And my bottom equation, or the one that's below it, is my line. So the top equation is x squared plus 3 minus the bottom, x plus 1. So we're going to subtract those first and then integrate. Please don't forget to use the parentheses because we have to distribute that negative. So x squared plus 3 minus x minus 1. If we make it like terms, x squared minus x, and 3 minus 1 is 2. And we're going to integrate this from -1 to 2 dx. And that will give you the area between the two curves. So take a couple minutes, type that into the calculator, and then hit resume when you're ready. Okay, so I got 7.5 for my area. Again, you could always use units squared. You know, that's something that's always useful. But let's look at now how this relates to what we did before. So this was our two answers from the first slide. So we had the entire area from here down was 12, and the entire area from here down was 4.5. I wonder if we subtract these two things, if we'll get our 7.5. So take a minute, type this into the calculator, and see what you get. And then hit resume when you're ready. All right, well, you should have gotten 7.5. And to be honest with you, you could always do it like this if you wanted. You could separate them both, take them, and then subtract them. But I think it's a little bit easier to just subtract right away and then use the integral. So that was really the purpose of me showing you that. All right, let's try another example. So these are the types of examples that you're going to have. They're not going to have graphs. They're just going to basically say, find the area between this curve and this curve over a specific interval. So it's really your responsibility to draw the sketch. So I'd like you to take both of those, put them in the y equals, and draw just a very short sketch of what the picture looks like. And then hit resume when you're ready. Okay, so the first graph that I have looks a little something like this. This is the first one. And the second graph looked a little something like this. So it's important that you know which graph was which. So this was my x squared minus 4x plus 10. And this one was my 4x minus x squared. And I want to find the area between these two curves from approximately 1 to 3. So 1, 2, and 3. So those are the values that I want to find the area between. So I want from here to here, but between the two graphs. So let's sketch it in so you can see it. So from about here to here. So if we follow the same pattern from before, it's the formula. We don't have to do them separate. We can just say, okay, it's the interval over a to b of the top equation minus the bottom equation dx. So it's clear that the top equation is this x squared minus 4x plus 10. So that's important to, at least for the graph, to know that piece. So the top, we're just going to type in as x squared minus 4x plus 10. And the bottom is 4x minus x squared. And again, please don't forget that minus because we're going to have to distribute that negative. So we have x squared minus 4x plus 10 minus 4x plus x squared. And then we can just combine like terms. X squared plus x squared is 2x squared. Negative 4x minus 4x is negative 8x, and then plus 10. And I'm going to integrate that over the interval of 1, 2, 3. So go ahead, take a minute, type that into the calculator, and hit resume when you're ready for the answer. Okay, so I got about 5.3 repeated, we could just say units squared. I didn't specify what to round to, so don't stress about the rounding, but that is approximately the area in this space between those two curves. All right, let's try one more. Okay, so I want to find the area between these two curves. If you think you can try this on your own, now's a good time to pause the video and see if you have the right answer. So what I'm going to do now is I'm going to ask you to draw a sketch. So again, same as before, draw a sketch of the two pictures so you know which one's on top and which one's on the bottom. So once you do that, hit resume. Okay, so the top graph is this guy, x squared plus 2, and my bottom graph is my negative x squared graph minus 2. And I want to find the area under the curves, or between the curves, excuse me, from negative 2 to positive 3. So realistically, I want all of this space from here to about here. I want the area between those two curves. So it's clear which one the top is and which one the bottom is. Whoops, sorry about that. Let's erase that. So my top is x squared plus 2 minus the bottom, negative x squared minus 2 dx over the interval from negative 2 to 3. All right, so what we're going to do now is we're going to distribute that negative here and simplify. So we have x squared plus 2 plus x squared plus 2, which simplifies to 2x squared plus 4. And we're going to integrate that over the interval of negative 2 to 3 dx. So go ahead, pause the video, take a minute, type this in, and hit resume when you're ready for the answer. Okay, I got about 43.3 repeated. Don't forget to put the units squared and then that's the final answer. I didn't specify how to round, so don't stress about that until the directions say so. So yeah, that's it for today. If you have any questions, please let me know.